The process of circuit design can cover systems ranging from complex electronic systems all the way down to the individual transistors within an integrated circuit. For simple circuits, the design process can often be done by one person without needing a planned or structured design process. But for more complex designs, teams of designers following a systematic approach with intelligently guided computer simulation are becoming increasingly common. In integrated circuit design automation, the term circuit design often refers to the step of the design cycle which outputs the schematics of the integrated circuit. Typically, this is the step between logic design and physical design. Formal circuit design usually involves the following stages. Sometimes, writing the requirements specification after liaising with the customer, writing a technical proposal to meet the requirements of the customer specification, synthesizing on paper a schematic circuit diagram, an abstract electrical or electronic circuit that will meet the specifications, calculating the component values to meet the operating specifications under specified conditions, performing simulations to verify the correctness of the design, building a breadboard or other prototype version of the design and testing against specification, making any alterations to the circuit to achieve compliance, choosing a method of construction as well as all the parts and materials to be used, presenting component and layout information to draftspersons, and layout and mechanical engineers, for prototype production, testing or type testing a number of prototypes to ensure compliance with customer requirements, signing and approving the final manufacturing drawings, post-design services. Specification. The process of circuit design begins with the specification, which states the functionality that the finished design must provide, but does not indicate how it is to be achieved. The initial specification is basically a technically detailed description of what the customer wants the finished circuit to achieve and can include a variety of electrical requirements, such as what signals the circuit will receive, what signals it must output, what power supplies are available and how much power it is permitted to consume. The specification can also set some of the physical parameters that the design must meet, such as size, weight, moisture resistance, temperature range, thermal output, vibration tolerance and acceleration tolerance. This can involve tightening specifications that the customer has supplied, and adding tests that the circuit must pass in order to be accepted. These additional specifications will often be used in the verification of a design. Changes that conflict with or modify the customer's original specifications will almost always have to be approved by the customer before they can be acted upon. Correctly identifying the customer needs can avoid a condition known as design creep, which occurs in the absence of realistic initial expectations, and later by failing to communicate fully with the client during the design process. It can be defined in terms of its results. At one extreme is a circuit with more functionality than necessary, and at the other is a circuit having an incorrect functionality. Nevertheless, some changes can be expected, and it is good practice to keep options open for as long as possible because it's easier to remove spare elements from the circuit later on than it is to put them in. Design. The design process involves moving from the specification at the start to a plan that contains all the information needed to be physically constructed at the end. This normally happens by passing through a number of stages, although in very simple circuit it may be done in a single step. The process normally begins with the conversion of the specification into a block diagram of the various functions that the circuit must perform. At this stage, the contents of each block are not considered, only what each block must do. This is sometimes referred to as a black box design. This approach allows the possibly very complicated task to be broken into smaller tasks which may either be tackled in sequence or divided amongst members of a design team. Each block is then considered in more detail, still at an abstract stage. but with a lot more focus on the details of the electrical functions to be provided. At this or later stages, it is common to require a large amount of research or mathematical modeling into what is and is not feasible to achieve. The results of this research may be fed back into earlier stages of the design process. For example, if it turns out one of the blocks cannot be designed within the parameters set for it, it may be necessary to alter other blocks instead. At this point, it is also common to start considering both how to demonstrate that the design does meet the specifications, and how it is to be tested. Finally, the individual circuit components are chosen to carry out each function in the overall design. At this stage, the physical layout and electrical connections of each component are also decided. This layout commonly taking the form of artwork for the production of a printed circuit board or integrated circuit. This stage is typically extremely time-consuming because of the vast array of choices available. A practical constraint on the design at this stage is that of standardization. While a certain value of component may be calculated for use in some location in a circuit, if that value cannot be purchased from a supplier, then the problem has still not been solved. To avoid this, a certain amount of catalog engineering can be applied to solve the more mundane tasks within an overall design. Costs. Proper design philosophy and structure incorporates economic and technical considerations and keeps them in balance at all times, and right from the start. Balance is the key concept here. Just as many delays and pitfalls can come from ill-considered cost-cutting as with cost overruns. Good accounting tools is imperative for a successful project. Manufacturing costs shrink as design costs soar, is often quoted as a truism in circuit design, particularly for ICs. Verification and testing. Once a circuit has been designed, it must be both verified and tested. Verification is the process of going through each stage of a design and ensuring that it will do what the specification requires it to do. This is frequently a highly mathematical process and can involve large-scale computer simulations of the design. In any complicated design, it is very likely that problems will be found at this stage and may involve a large amount of the design work be redone in order to fix them. Testing is the real-world counterpart to verification. Testing involves physically building at least a prototype of the design and then checking the circuit really does do what it was designed to. Prototyping. Prototyping is a means of exploring ideas before an investment is made in them. Depending on the scope of the prototype and the level of detail required, prototypes can be built at any time during the project. Sometimes they're created early in the project, during the planning and specification phase. Later in the cycle, packaging mock-ups are used to explore appearance and usability, and occasionally a circuit will need to be modified to take these factors into account. Results. As circuit design is the process of working out the physical form that an electronic circuit will take. The result of the circuit design process is the instructions on how to construct the physical, electronic circuit. This will normally take the form of blueprints describing the size, shape, connectors, etc. in use, and artwork or CAM file for manufacturing a printed circuit board or integrated circuit. Documentation. Any commercial design will normally also include an element of documentation. The precise nature of this documentation will vary according to the size and complexity of the circuit as well as the country in which it is to be used. As a bare minimum, the documentation will normally include at least the specification and testing procedures for the design and a statement of compliance with current regulations. In the EU, this last item will normally take the form of a CE declaration listing the European directives complied with and naming an individual responsible for compliance.